and I will talk to any community leader, person. If you've got a pulse, I will talk to you about this. I'm not a very interesting person at parties, by the way. Okay, well, first of all, this is one of my favorite cartoons. It's done by Ed Stein. It was originally done in 1977, and he redid it for ASPO in 2009. It says, buffalo shortage? What buffalo shortage? Give me enough money for guns and scouts, and I will get you all the buffalo you need. Unlimited resource. The best thing about buffalo is they're renewable, aren't they? But if you harvest them too much, they're not sustainable. Those two words are not interchangeable. Sustainability and renewability are not equal. So don't forget that, because there will people talk to you all the time about renewable resources or sustainability, and they somehow don't keep the two connected. Do a look at Port Townsend, and I'm actually going to give you a case study of a situation that probably most of you are not even aware of here, which is probably one of the best peak oil solutions that, to transportation problems. To start with, I realize this isn't really easy to see because it's actually a background, but it's a bell curve. It's a traditional resource curve. And the idea behind it is once you've consumed half of a resource, your rate of extraction will begin to decline. This is actually a copy of Emma King Hubbard's original publication predicting the peak of oil globally in the year 2000, but key one was he picked the peak for U.S. oil production in the early 1970s, and that's exactly when the United States peaked at oil production. November 1970, the United States produced 10 million barrels of oil. It's one of only 3 countries in the world to ever reach that mark. Saudi Arabia and Russia are the only 2 other countries in world history to produce 10 million barrels a day of oil. So what is peak oil? Well, I'm going to tell you what it's not. It is not running out of oil. There will be oil on this planet in the ground when the last human being has checked out and gone. It's not running out of oil. What it is a matter of flow rates. It's how fast we can extract it. So we're going to look at a couple of things here. First, what's a resource? Resource is how much is in the ground. It has no bearing on whether you can get it out of the ground or not. It's what's there. Then the reserves are what you can actually extract. So when you hear people talking about trillions of barrels, they're probably talking about the resource. The reserve is what is extractable and usable at current technologies and costs. That's the number that pays attention to. Even more important than that, though, is the flow rate. What is the rate that we can get it out? And I'll give you a very good example. If you have a checking account with $1 billion in it, you have a huge resource base. But if you can only take $1 a day out, you have an abysmal flow rate. Off the coast of Brazil, there is billions of barrels of oil. Their estimates that you read in the paper are completely on the mark. In fact, they may even be too low. But the flow rate from those fields like the Tupi off the coast of Brazil will be very low. They're in 6,000 to 8,000 feet of water. They're drilling down as deep as 28,000 feet. That's like drilling to the top of Mount Everest to get oil. And they're 250 miles off the coast. This is not cheap or easy. This is the required peak oil chart. If you're going to give a peak oil talk, you have to have this one. The red is the discoveries. You can see back in the late 40s, early 50s, this is when the big Ghawar field and Burgan field in Kuwait, it's Burgan, and Ghawar is in Saudi Arabia, were discovered. These are some of the other big discoveries, but 1968 was the peak year. After that, there was no major oil discoveries anywhere near the scale of those in the Middle East. We had some little bumps over in here in the late 70s, but the trend is down. The black line is our consumption. We're consuming somewhere in the neighborhood of 5 barrels of oil for every we're consuming 5 for every 1 we discover. Simple arithmetic says you can't continue on that. So the question is, what happens out here? At some point, the supply will get squeezed. This is the very first time that the IEA has admitted that depletion, that is the rate that production is declining, was a big problem. Despite all the attention that is given to demand growth, most people think of China and India as demand growth. The decline rates are actually far more important determinant of investment needs. Even if oil demand was to remain flat to 2030, in other words, flat at the current level of around 88 million barrels a day, we still need 45 million barrels a day of gross capacity. 4 Saudi Arabia's worth of production capacity would need to be built by 2030 just to remain flat. Does anyone in this room know where we've got 4 Saudi Arabia's? There's one. Does anybody know where it is? There's one country with that kind of capacity. Iraq. Exactly. They could theoretically go to maybe 10. So there's one. Now what we got to do is find 3 more. But that was assuming no economic growth. If we follow the historic trend in economic growth, the IEA says we need 6 Saudi Arabias. The oil off the coast of Brazil was not a surprise. The geologists knew it was there. It was a matter of whether we had the technology and the money to go get it. And we get to $100 oil, you can afford to go get it. How many people recognize that kind of picture? Check out the year of the cars. 1970s, lined up at a Texaco station. Can't find very many of those around anymore. This is from this November, their report issued in November of this year, or excuse me, of 2010. It says crude oil output reaches an undulating plateau of 68 to 69 million barrels by 2020, but never regains its all-time peak of 70 million barrels a day reached in 2006. The IEA just told you that crude oil production peaked in 2006. How many times have you heard that from the Department of Energy? That crude oil production peaked in 2006. You haven't, of course. Now, there's one caveat here, and that is that the IEA is talking about crude oil. They're not including biofuels, they're not including unconventional deep water oil, and they're not including Arctic oil. So, this is traditional, think of the Oklahoma oil well. The guy's out there, drills a hole in the ground, oil comes up, he's filthy rich, he's dancing. You know. That's crude oil. So the numbers get a little goofy because according to the Energy Information Administration here in the United States, we consume about 88 million barrels a day of liquids. But that includes, again, biofuels and a whole another batch of things that we wouldn't call traditional crude oil. So what is the scale of the task that the world's confronting with this peak oil problem? This is a chart showing the primary energy sources that humans have used since 1850. The red is biomass. Now, in 1914, 30% of the farmland in the United States was dedicated to feed the horses that worked the farm. 30% of the land was biofuel because the farms were operated on muscle power. By 1929, all of that land was under cultivation for crops. Now you know why food prices collapsed in that 20-year period. Farmers couldn't make any money because they'd gone from being based on animal labor to gasoline and diesel power. But you can see that the use of biomass worldwide really hasn't declined very much. This is not cumulative, this is annual. So this is what we were taking in annually back here. These are the annuals now. So then we go to coal, oil, natural gas, nuclear, and then there's a little tiny sliver at the top for other. So these are fossil fuels, non-renewable fossil fuels. Which one of those primary energy sources replaced the one that preceded it? Remember, this is cumulative. None of those replaced any of the ones that came before. The coal was stacked on top of the biomass, the oil was stacked on top of it. It's a layer cake. Humanity, in replacing coal or oil or natural gas, is going to have to do something it's never done before. We have to replace a primary energy source. I want to make a point here. Primary energy is different than something like, a lot of people say, well, just use hydrogen. Hydrogen is a storage form. It's not a primary source of energy. Primary source would be used to produce hydrogen or charge a battery. 95% of all the transportation of goods and people in the world is done with oil. 95%. Coal is not a renewable resource. Someday we'll run out of it. There is far more of it out there than most people would like to face up to. But it will not last forever, and the quality of it is falling. Oil is not renewable. Natural gas isn't renewable. Nuclear is not renewable. The ones which we can count on being there is getting rather small in the future. So the question comes, what about biomass, biofuels, bioethanol, diesel, and such? Well, they're renewable, but remember what I started out and said. If you over-consume them, they're not sustainable. That's the problem they ran into with whale oil. Whales are renewable, but if you harvest them too rapidly, they're not sustainable. Then down in the corner, we have the true renewables. Hydropower globally is essentially maxed out. In fact, as you know, out on the peninsula, we're taking dams down now. The other renewables, 1% of global primary energy comes from renewables. Wind, tide, solar, 1%. Average growth in energy demand is over 1% per year. So if global demand grew 1% and renewables grew 100%, would their share change? 100% annual growth in renewables would be canceled out by a 1% growth in total demand. We've got a huge task ahead of us. This graph was done by a friend of mine named David Hughes. He's with the Post-Carbon Institute, but at the time he did this graph, he was with Resource Canada, and he was responsible for their natural resource reporting. And what it is, it's a graph of cumulative. Now this is different than those earlier graphs I showed you. Those were annual. This is total oil consumption. Now I'm sorry, it only goes through 2005. I've been on David's case to get me a new one. So this is actually going to make things look a lot better than it is. So this is underneath this curve is the total oil consumed since we started consuming back here in the 1850s. Total consumption up to here. And you can see this line is starting to go exponential. It's starting to go straight up. 1958, it's right here. 90% of all the oil. You actually need to adjust that for today's consumption. It's now over 95%. Since I entered the first grade in 1958, we've consumed 95% of all the oil ever consumed by humanity. My 27-year-old son, who by the way works with me and is the brains of our operation, I'm just the front man, was born in 1983, just very late in the year. During his lifetime, he's seen 55% of all the oil ever consumed in the world. Consumed. 27 years old, and he's seen over half of the oil humanity has ever consumed be done while he's been alive. You high school students, imagine what it's going to be by the time you guys are our age. You probably will have seen very nearly 100%. That blue portion, that's how much of the total that's been consumed in my period since first grade. This is an amazing one. A friend of mine who's active in ASPO as a financial advisor back in Virginia sent me a note. He says, did you ever look at the oil consumption in World War II? I said, no, I've never really thought about it. He says, if they add up all the oil consumption during the entire 7 years of World War II, it's equal to 6 months consumption today. That blue block is World War II. And we consume an equivalent amount every 6 months. If you were born in 1940, you've seen 98+% of all the oil consumed in the world in your lifetime. Have you got the thing about scale now a little bit? It's the big numbers we're dealing with. In 1999, you could go 3,000 miles on $500 worth of diesel fuel at 6 miles per gallon, which I'm told by the guys from the barging company that's here is a pretty accurate number. 2001, you got to here, $500 of fuel. 2004 was here, 2007 is here. 2008, you didn't even get out of the state. 2010, or today essentially, is right here. If we go back to the diesel fuel prices of 2008, they'll still be inside South Carolina with $500. You see what that does to the economics of shipping? It changes the whole scenario of the economy, and it happened very fast. Lots of people, I love this picture, by the way. Actually, if you've been to Lake Forest Park, where the intersection of Lake City Way and Ballinger is, that's actually the new intersection we're putting in. No, how many people, the 405 Bothell Way one's just as goofy. This is one of the best answers I can find to anybody that ever says, well, we just need to build more roads. You know, we've done that experiment, and it's called Los Angeles. Building new roads it's been proven to not be a solution. Not as conditions we have now. So if your idea of energy independence in the United States is that you can fill your tank for $1 a gallon or $2 a gallon, forget it. Not going to happen. Maybe we'll have $100 oil. We have $104 oil today. Malaysian Tapas, which is the highest quality oil in the world, is $104.70 a gallon, or barrel, excuse me. So there's already $100 oil out there. In fact, I follow 7 grades of oil. All of them were over $92 a barrel. 4 of them were at $99. So it just depends on where you're buying and what you're buying. I'm going to skip that one. Here's the price. This is the fourth quarter, average price of oil in the fourth quarter of 2005, 2006, 2007, 2008, because the price went in the toilet, 2009, and here in 2010. So we're at $82 a barrel in 2007 when we entered a recession, and we're at $80.71 in the fourth quarter of 2010. We are not far off that price that cracked the economy. Whenever oil has reached 4% of GDP, which is this line right here, we've had a recession. Steve's up here going, God, you're finally getting to the good stuff. Okay, so here, why would anybody buy one of those things, given what I just told you?
Sleep in it.
To sleep in it. You know, actually, I think that is maybe bigger than my bedroom. I guess, I mean, can you imagine, I mean, any of you high school guys are thinking of going to engineering. I mean, could you have designed anything sillier, you know, like a 7,000 or 8,000 pound vehicle to move a 120 pound woman to the grocery store for half a gallon of milk? Well, actually, it probably was an economically reasonable and rational thing to do back in 1998, 99, 2000. In fact, it was so rational because in the state of, this is from the state of Washington data, from the Department of Transportation, the amount of miles driven by Washington state citizens went up from 1970 to 2000. We drove more miles in this state. At the end, I mean, we really learned a good lesson. But you see, it was cheaper than it had ever been in history to do it. This is back there in 98, 99. The cost per mile was the lowest it had ever been. It was totally rational. It was cheap. In fact, you could probably argue that it was free. A gallon of gasoline contains roughly 200 man-hours of labor. So for $3, you can get as much work done as hiring 200 slaves for an hour. I'd put that pretty close to free. I mean, some people say, well, that can't possibly be true. Well, I can go get in my Volvo, with 4 other adults, and it will take me 30 miles down the road on 1 gallon of gasoline at 60 miles an hour. So in 30 minutes, it'll take 5 of us, 30 miles down the road. It'll cost me $3. Now, how many of you would be willing to go get your donkey cart and do that same task? Move my 5 friends and me and my car 30 miles down the road for $3. Oh yes, you got to do it in 30 minutes too. For $3. It's free. In fact, the most of the time that you think about your gasoline when you're buying it is when you're buying it. The minute you pull out of the gas station parking lot, I guarantee it's out of your mind. Therefore, it is free. Does it surprise you then that we would buy those big trucks? By the way, in 2000, it was an interesting year, the Ford company introduced the Excursion, and 6 months later, Toyota introduced the Prius to the United States. And that same year, there were 500,000 Ford Explorers sold. It's free. But not for everybody in your community. If you're a rural resident of Montana, it's taking 12.7% of your income to buy gasoline. In fact, in getting ready for this last week, I wanted to know more about Jefferson County, so I started digging into it, and I started finding this information about rural gasoline consumption. And rural consumers, folks in South Carolina, Mississippi, Louisiana, these people are highly sensitive to the price of fuel because they consume about 40% more than the average American consumer of fuel. So now that means the Jefferson County rural resident has a different energy concern than the person who lives on the hill over here and can walk to town. If we take the 1999 price and we adjust for the change in the price of oil, a consumer in the rural household would have spent $500 more in 2000 than they did in 99. Not too bad. This is inflation adjusted, by the way, $2,010. But look what happened in 2008. That household was now spending $2,500 more for fuel. That's more. In other words, the actual cost is about $3,500. Here we are in 2011. If we go to $4 gas in the United States, the average rural resident will spend $6,000 on fuel. The average rural household doesn't earn $100,000 a year. These people will see gasoline approach 20% of their pre-tax household income. Now you know why we run the risk of a recession. But from the perspective of you folks that are active in your county's government, you have an interesting county, don't you? Somebody plopped a national park down in the middle of you. I suggest you might want to take a look at how they run this county when cheap fuel wasn't so abundant. And how is it going to impact those people? Because they're highly sensitive to the cost of fuel. This is from that Lloyd's of London report. I'll go through here. Businesses which prepare for, if you have a business, listen carefully, and take advantage of the new energy reality, you're going to prosper. Failure to do so could be catastrophic. They didn't say bad, they didn't say tough. Catastrophic is the word they used. Market dynamics and environmental factors mean business can no longer rely on low-cost traditional energy sources. Now, here they're speaking even beyond just oil. Because electricity will become a problem, but not yet. We're heading towards a global oil supply crunch and a price spike. Their estimate, by the way, was 2015-2016. Business must address energy-related risks to supply chains and the increased vulnerability of just-in-time inventory. I'm going to come back to Harborview for 1 second. My wife works down there. I pick her up periodically in the evening, and if I'm if I'm lucky enough, I get to be there when the Cardinal Health truck rolls up every night with a just-in-time inventory supply to keep the hospital going. You know, Walmart can work on just-in-time inventory, and if I don't get my Lego bricks delivered in time, that's okay. But if the IV bags don't show up, we got a problem. So Just-in-time inventory is dependent on that nearly free fuel. So is the idea of bringing goods from China. Arbitraging cheap labor in China requires cheap fuel. My son bought a bookcase the other day, took it home, got it at Target, got the lowest price bookcase he could get. It was manufactured in Iowa, not China. Particle board's heavy. It costs a lot of money to transport it. And if you can automate a lot of work, you can build it here as cheap as you can in China now. Globalization? Maybe. Okay, I want to talk a little bit about kind of a cool case study. Barges versus trucks. And the proud owners of this barge happen to be here, by the way. This barge, which hauls paper from the mill out here. How many people knew that was going on, by the way? That the mill was shipping all their paper by barge? Yeah. It's not, you know, this barge takes 60 truckloads off the road. Now, if you're Jefferson County, that's good news. Because that means your roads are going to last longer. Right? But that's just one barge trip. They make 4 loads a month. They take 48 trips a year. That's 2,880 truck trips. That's a lot of impact removed from the roads. Even better is that it removes 105,600 gallons of diesel fuel consumption. So if you're interested in carbon, this is a home run. The fuel savings for each truck, 615 gallons. Anyway, you do the math, but these trucks get about 5 miles per gallon. I was astounded to hear that. That's about the same as I understand a large motorhome gets. A brontosaurus, motorhome. That someday they will be extinct. So you reduce road traffic, you reduce road damage. They don't typically take the trucks off the ferries, but imagine what that does also to the ferry space available for passenger vehicles. So Port Townsend got here for a reason. There's a town here for a reason. Your past has answers to your future. How did this town function in 1910? How did things work? You high school guys looking for a senior project, a research piece, something to do? Volunteer to the county to research that project. How did this town work? Because maybe in your past there's some great clues to your future. Just like the airline industry probably needs to look at its past or its future. This is a great example of a peak oil solution. The economy doesn't have to stop. If you only listen to the bad part of what I told you earlier, which is that the world's going to end on it, and you didn't take a creative point of view and look around, because in every bad scenario there's opportunity. There was a lot of money made when everybody was jumping out of the windows in 2008 and 2009. Be prepared. Think through the scenarios. So first thing, you got to quit dreaming about liquid fuel energy independence. Not going to happen. You'll notice I didn't say electric cars. I said liquid fuel energy independence. Stop building liquid fuel-based infrastructure. You probably don't need to ask me what I think of the third runway at SeaTac or the tunnel in Seattle. My kids are going to be paying for both for the rest of their lives, and they won't need them. Changes in transportation. Now here's one key point though. Differentiate between freight and people. Freight constitutes a much larger volume and a much larger consumer of that critical diesel fuel. Most of the time when you hear people talk about transportation issues, it's almost always moving people. But if we don't keep commerce working, we won't need to move people. Energy efficiency and conservation is the cheapest, lowest hanging fruit. Use land use changes, and Andy's going to love this. I live in Lake Forest Park. We have a tree cutting ordinance. Do you guys have those here? I have thermal hot water solar in my house. I installed it in 1980. It works great. Okay? My neighbors can't put solar on their house because they have some trees. And they can't cut them down. So here I live in this town of Lake Forest Park that thinks it's so green, and they've arranged it so that my neighbor can't put solar on his house. There are compromises will have to be made. So think about land use policy, regulation. There's no clear-cut answers to any of these things. And then finally, again, how did Port Townsend function 100 years ago? How did it function 60 years ago? What worked, what didn't work? What was done here that now is done in China that might have to come home? There's your opportunity. Okay? There's opportunity here for those who want to take and think it through. Finally, these are two most important quotes that I go with. My first one is on my email all the time. It says, it's difficult to get a man to understand something if his salary depends on not understanding it. If you go to the Boeing company and try to convince them that we're going to have a jet fuel supply problem, you wasted your time. Try General Motors. No way. They build cars. Try someone who has built a lifestyle dependent on cheap fuel. They're going to have a very hard time grasping what I just said. And then finally, and this is my view of the world, we did not inherit the earth from our parents, we're borrowing it from our kids. We're borrowing the earth from these high school kids in this room. We're going to give it back to them in better shape than we found it. My dad said, you borrow a saw, you sharpen the saw before you return it. Well, we've not only rusted the saw, we've broken the saw, and we pretty much chucked it in the trash. So we need to get our heads turned around. We need to give to our kids the world we've borrowed from them in better shape. So anyway, on that, I will take a break, and then I'll come back and I will answer all those questions I know we're just eating at you.